We're going to continue our study on inequalities today, particularly talking about absolute value inequalities. Now, when you're working with absolute value inequalities, you're going to have one of two types of problems. In the first type, we'll have an absolute value that's less than something on the right-hand side, and that is the same as writing it as two separate inequalities where r is less than k and r is greater than negative k. And we call this a conjunction. Second, we have the second case where you have the absolute value is greater than the other side. And in this case, you have either r is greater than k or r is less than negative k. And we call this a disjunction. Now, what's going to end up happening when you solve these absolute value inequalities is that in a conjunction, you'll end up with just one section of solutions, whereas in a disjunction, you'll have two sections of solutions. So take a look at example 4. We have 3x minus 7 within the absolute value is less than or equal to 11. Give your answer in interval notation and graph your solution. Now, because I see that we have an absolute value that's less than or equal to a number, we know that this is going to be a conjunction. That means I can write two separate inequalities and write an AND statement in between. So that would be 3x minus 7 less than or equal to 11, and 3x minus 7 is greater than or equal to negative 11. Now we'll solve each inequality separately, and then we'll put them back together. So from the first one, we have 3x less than or equal to 18, which is equal to x less than or equal to 6. On the second inequality, we have 3x greater than or equal to negative 4. Divide both sides by 3, we have x greater than or equal to negative 4/3. Now we're going to combine both of these statements. This says that x is less than or equal to 6 and greater than or equal to negative 4/3. So to write it as one statement, we would write negative 4/3 is less than or equal to x, which is less than or equal to 6. Because x can equal negative 4/3 and 6, in interval notation, we would write this with square brackets. So this would be square brackets, negative 4/3, comma 6, with a square bracket at the end. Now to draw this on our number line, we would first want to find negative 4/3 and 6. So let's say 0 is here. Then negative 4/3 would be right around here. It's negative 1 1/3. And 6 would be here. And because x can equal both of those values, we will have solid points at negative 4/3 and 6. And then we'll shade everything in between. So notice how here our solution set is just one section of the number line. Let's look at another example. The absolute value of 5x plus 2 is greater than 3. We'll take it apart the same way, but notice in this case we have a greater than sign. This means that we are going to have a disjunction. So at the end we should have two separate sections of our number line that are colored in. So let's write our two separate inequalities. That would be 5x plus 2 is greater than 3, or 5x plus 2 is less than negative 3. In the first inequality, we can subtract 2 from both sides. We'll have 5x is greater than 1. Divide by 5, we have x is greater than 1/5. In the second inequality, subtract 2 from both sides. We have 5x is less than negative 5. Divide both sides by 5, we have x is less than negative 1. And so combining both of these statements, we're saying that x is greater than 1/5 or x is less than negative 1. Notice that there's no way for us to say that x can be both. It has to be either greater than 1/5, and that would be positive, or less than negative 1, and that would be a negative number. So we clearly have two separate sections of solutions here. Now to write this in interval notation, the first section, the x is less than negative 1, means that x can be any number from negative infinity all the way up to negative 1, but not including negative 1. For x is greater than 1/5, x can be any number starting from 1/5, but not including 1/5, all the way up to infinity. So we can write those two intervals and combine them with the union symbol. Now on the number line, we are going to go ahead and find 1/5 and -1. And we know that x cannot actually equal -1 or 1/5, so we are going to have open circles. Now for -1, we know x is less than -1, so we can fill in everything to the left of it. For 1/5, we know x has to be greater than 1/5, so we can fill in everything to the right of it. And now you can see very clearly there are two separate sections of solutions to this inequality. One last example. We have 1 minus 4x over 2 plus 3x, all inside the absolute value sign, is less than 1. All right, so first thing to notice is, although we have a fraction, this is still a conjunction. Next, we can write out our two separate inequalities just like we were doing before. So 1 minus 4x over 2 plus 3x is less than 1. And then 1 minus 4x over 2 plus 3x is greater than -1. Now for the one on the left, we'll go ahead and multiply both sides by 2 plus 3x so that we no longer have a fraction. Multiply that out, and then let's subtract the 3x over to the left. 1 minus 7x is less than 2. We'll subtract the 1 over to the other side. So now we can divide both sides by -7. Don't forget to switch the inequality. So now we have x is greater than -1/7. In the second inequality, we'll do the same thing. We will multiply both sides by 2 plus 3x and get rid of that denominator. Multiply that out, and we have 1 minus 4x is greater than -2 minus 3x. We'll go ahead and add 3x over to the left. Subtract the 1 over to the right. And now we have to divide both sides by -1. So we will have to switch the inequality. So now it says x is less than 3. Now it is a conjunction, so we can write this as -1/7 is less than x, which is less than 3. Now we want to give our answer in interval notation, so we will use parentheses here. So that would be parentheses -1/7, comma 3. Now we still need to graph our solution, so let's draw out our number line here. We'll find -1/7 and 3. And we know that our solution x cannot be actually equal to -1/7 or 3, so we are going to put open circles on those. All right, and then this is everything in between those, so we can go ahead and shade everything in between. So just as a summary of what we talked about today, we did absolute value inequalities, and we first determined whether or not it was a conjunction or a disjunction. And the way we determine that is we look at whether we have a less than or equal to versus a greater than or greater than or equal to symbol. And then use that to determine whether you have just one section of solutions or if you have two separate solution sets.